Hello dear students, once again welcome back to our channel. In this video we are continuing exercise 6.2, question number 6. Here A, B and C are points on OP, OQ and OR such that AB parallel to PQ, AC parallel to PR. We have to show that BC parallel to QR. Question is clear, children? Okay, then see children, how can we show that this BC parallel to QR? Okay, we have solved so many problems of this type to show that a line is parallel to one side of a triangle. We are using converse of basic proportionality theorem. Okay, and for that we have to show that the other two sides of the triangle must be divided in the same ratio. Idea is clear, children? What is our aim? Okay, that means we have to consider triangle OQR. Okay, we have to show that BC parallel to QR. So, other two sides are OQ and OR. Okay, if you can show that these two sides are divided in the same ratio, that means OB by BQ equal to OC by CR. That means we can say that this BC is parallel to QR. That is what we are going to show. Okay, this is why, because converse of basic proportionality theorem. Okay, and for that, in order to reach into that answer, we have given that AB parallel to PQ, that is given. Okay, since AB parallel to this side PQ of this triangle PQR. See children, this not PQR, triangle POQ. Okay, see children, which line is parallel to which side of a triangle? Okay, and for that here you have to first consider triangle POQ, this triangle, children, this triangle. Okay, and in this triangle AB is parallel to PQ, that is given. AB is parallel to PQ, this is given. Okay, in all problems you have to start with in this manner. What is given? Okay, what we need to prove, that we have to write first. Okay, yes, since AB parallel to PQ, okay, so we have to consider first a triangle POQ. Okay, so in triangle POQ, okay, since AB parallel to PQ, in triangle POQ, okay, by basic proportionality theorem, by BPT, you can write what you can write from this vertex O, we can write, okay, that means OA by AP, okay, OA by AP equal to, if you start from this vertex, this side also you should start from this vertex, okay, that is OB by BQ. Idea is clear, children? That means I consider this side, that is OA by PA or AP, and same way OB and BQ. Okay, since AB is parallel to PQ. And also we have given AC parallel to PR. AC parallel to PR. PR is a side of triangle POR. Okay, so we have to consider that triangle. Okay, so in triangle, the second triangle is POR, this triangle. Okay, that means in triangle POR, okay, since AC parallel to PR by BPT, okay, what you can write? You can start from this vertex O, okay, that means OC by CR, okay, the other two sides are OR and OP. These two sides are divided in the same ratio. Okay, why? Because this AC is parallel to this side PR. That is the next step. Okay, that is OA by AP equal to OC by CR. The other two sides are divided in the same ratio. Okay, that is by basic proportionality theorem. So, this can be equation number 2. See, look into these two equations, children. You can see that both the equation OA by AP, OA by AP. That means one side is the same. That means you can equate the other two sides. Okay, since LHS are the same, which implies you can equate the RHS part. Okay, that means from 1 and 2, from 1 and equation number 2, okay, since OA by AP are both the same, which means OB by BQ, RHS can be equated OC by CR. It is clear? Okay, we have applied basic proportionality theorem upon these two triangles OPQ and OPR, and now we have seen that these two sides are divided in the same ratio. See, children, this OQ and OR are the sides of the triangle OQR. So what we have seen in this triangle, those two sides are divided in the same ratio. Okay, that means if you mark this as equation number 3, okay, so what we have seen, so in triangle OQR, this triangle, in triangle OQR, okay, from 3, what you can write? We have this relation OB by BQ equal to OC by CR. See, children, OB by BQ, OC by CR, which means this BC is parallel to, okay, from triangle OQR, we have seen this one OB by BQ equal to OC by CR, which means this BC parallel to QR by converse of BPT. Idea is clear? This is all about the 6th question. Now the 7th problem. Prove that if a line drawn through the midpoint of one side of a triangle parallel to the another side bisect each other. That is what we have to prove. That means we have a triangle ABC and I am drawing a line from the midpoint of one side of a triangle ABC. That means I am starting from the midpoint of the side AB. This is the midpoint, that is D. Okay, through this midpoint of AB, I am drawing a line parallel to this side BC. Okay, that means then what happens? What we have to prove? We have to prove that the other side, that is the third side AC, get bisected. That means if you draw a line parallel to BC from the midpoint of the side AB, which means this line D bisect the third side AC, get bisected. That means we have to show that AE equal to EC. So what is given? Given D is the midpoint of given in triangle ABC. In triangle ABC, D is the midpoint of side AB and DE parallel to BC. This is given. We have drawn DE parallel to BC. That means you can apply basic proportionality theorem. Okay, what is the statement? If a parallel line drawn. So by basic proportionality theorem, what you can write? Okay, that means if we have a parallel line, okay, drawn to the other two sides of a triangle in two distinct points, that means other two sides are that means you can use the basic proportionality theorem. That means DE parallel to BC. If so, these two sides AB and AC are divided in the same ratio. Okay, so by BPT, what you can write? Okay, since DE parallel to BC, okay, AD, the other two sides are divided in the same ratio. EC. This can be equation number 1. In the question itself, it is given that DE is parallel to BC And also one more thing is given. D is the midpoint of AB. Okay, that is given. See children, D is a line drawn through the midpoint of one side. Okay, that means here since D is the midpoint, midpoint of AB implies, that means AD equal to DB, right? This AD equal to DB. It is given that D is a midpoint, but we have to show that AE equal to BE. That is, we have to show that AE equal to EC. This is the required proof. Bisect the third side. This is the third side, so E is the midpoint. Okay. So for that children, here since AD equal to DB, D is the midpoint, can you write in terms of ratio? We have the ratio form, equation 1. So from this AD by DB, can you write like this? If you take DB, this RHS will be 1. See, AD equal to DB implies AD, the ratio between these two sides. Okay, these two portions equal to 1. See children, DB can be taken to this side. So, AD equal to DB, doesn't matter. So, this can be equation number 2. What we have seen? We have seen that AD, this ratio is 1. But from equation 1, this AD by DB equal to AE by EC. So, can you substitute this AE by EC also 1? Because we have seen that AD by DB equal to 1. Okay, so 1 becomes, I am going to substitute this value over equation number 1. Therefore, 1 becomes, that is in place of AD by DB, 1 equal to AE by EC. AE by EC also 1. Which means if you take EC into LHS, you can write EC equal to AE. EC equal to AE. See what is in the figure? EC equal to AE. Since EC equal to AE means E is the midpoint. E is the midpoint of AC, side AC. That is what we have to prove. We have to show that EC equal to AE or AE equal to EC, doesn't matter. Okay, that means we have seen that E is the midpoint of the third side AC of the triangle ABC. Okay. Now the 8th problem. Prove that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side. So we need a triangle, that means triangle ABC I have drawn, and D is the midpoint, that is given, and E is the midpoint. See children, line joining the midpoints. Okay, so D is the line joining the midpoints of this side AB and AC. And what we have to show? This DE is parallel to BC. See children, E is parallel to the third side is BC. Okay, so see children, here also we need the application of which theorem? How can we show that a line is parallel to the one side of a triangle? We are using the converse of basic proportionality theorem. And for that what we need? We have to show that these two sides are divided in the same ratio. If we can show that these two sides AB and AC are divided in the same ratio, that means AD by DB equal to AE by EC. So that you can write DE is parallel to B. So our aim is in order to get AD by DB equal to AE by EC. That is our aim. Let us see children how this can be obtained. Okay, using the under given statements. Okay, here what is given? D is the midpoint. Okay, since D is the midpoint means AD equal to DB. D is the midpoint. Okay, implies AD equal to this is equal to this portion. That means from this can you write AD by DB equal to 1? If you take this DB here 1. Okay, so this can be equation number 1. And also E is the midpoint of AC. E is the midpoint of AC. That means from this you can write another equation, that is AE equal to EC. See children, this AE and this portion EC are the same because E is the midpoint. Okay, and in the same, if I am taking this EC to its LHS under division, so RHS will be 1. That means this can be equation number 2. So what we have seen from equation 1 and 2? Okay, this AD by DB is equal to 1 and also AE by EC equal to 1. 1, 1. RHS being same, you can equate their LHS part. Okay, that means, so from 1 and 2, equation 2, you can write AD by DB equal to this LHS of the second equation AE by EC. Okay, see, if so, you see that what all things we got, AD by DB equal to AE by EC, that is the only thing we needed. We need to show that D is parallel to BC. This is sufficient. Okay, because of converse of basic proportionality theorem. From this, since the sides are divided in the same ratio, okay, which implies you can write this DE parallel to BC. Okay, why? Because here you can see that these two sides of triangle ABC divided in the same ratio. The ratio of this side equal to the ratio of the second side AC, which means this DE parallel to BC by converse of basic proportionality theorem. Now the 9th question, ABCD is a trapezium such that AB is parallel to CD and the diagonals intersect at the point O. We have to show that AO by BO equal to CO by DO. Okay, it's very simple proof. It's very important also, children. Okay, what is given? ABCD is a trapezium. Trapezium means if in a quadrilateral, any two sides are parallel. So that quadrilateral is what we call trapezium. So that means here AB is parallel to CD. See, since it is given that AB parallel to CD. Okay, see children, we are applying basic proportionality theorem and that is for the triangles. Okay, so we have to consider one triangle. Okay, and for solving this problem, we need a very important construction. That is, we have to draw a line parallel to the CD. That means through O, that point of intersection of the diagonals AO, AC and DB. Okay, from this point, we are drawing a line parallel to this CD, let it be OE. This is a construction. Without doing this, we can prove this required proof. Okay. So, what is the construction? Draw OE parallel to CD. See children, this help you to apply basic proportionality theorem. Okay, see children, see, so in triangle, see OE is a line parallel to CD. So, this CD includes this triangle. So, we have to consider triangle ADC. So, in triangle ADC, since this EO or OE parallel to CD, you can apply the basic proportionality theorem, which means the other two sides are divided in the same ratio. It is clear? Okay, that means consider triangle ADC. Okay, since OE is parallel to CD by construction. Okay, so by basic proportionality theorem, the other two sides, which are the other two sides AD and AC of triangle ADC, that is AE by ED equal to AO by OC. This is equation number 1. See children, since this OE is parallel to CD, it is given that ABCD is a trapezium such that AB parallel to CD, which means, can you say that this OE is also parallel to AB? See children, AB and CD are parallel and we have a line OE parallel to this CD. Okay, this is CD, this is OE and AB is already parallel with this CD. By construction, OE is parallel to CD, which means this OE is parallel to AB also. Understood? That means since OE is parallel to CD implies we have also given that AB parallel to CD, and now we have EO or OE. By construction, OE is parallel to CD, okay, which means these two lines AB will be parallel to OE. See children, what we have now? AB parallel to OE. See, these two sides are parallel. These two lines are parallel. And see children, can you apply basic proportionality theorem? Upon which triangle? See children, this OE is a line parallel to this AB of triangle ABO. Understood? So, in the second case, we have to consider triangle. In triangle ABO, we have to consider a triangle having the side AB. Okay, then only this OE is parallel to AB. That idea can be applied. Okay, that means in triangle ABO, okay, since OE parallel to AB, see OE parallel to AB means these other two sides, which are the other two sides of triangle ABO? AD and BD are divided in the same ratio. Understood? That means AE by ED equal to BO by DO by basic proportionality theorem. Since OE is parallel to AB, we have the other two sides are divided in the same ratio. This can be equation number 2. See 1 and 2, see children, AE by ED equal to AO by OC. Here AE by ED equal to BO by DO. So from 1 and 2, what you can see? You can equate its LHS. Being RHS, LHS are the same, you can equate their RHS part. Understood? That means I am going to equate their RHS of equation 1 and 2 as AO by OC equal to BO by DO from 1 and 2, equation 1 and 2. But what we need to prove? AO by BO equal to CO by DO. Just a rearrangement is needed from this. See children, if you take this OC to this side, you can automatically BO will come to this denominator in the LHS. So you can rearrange in order to get the answer. We are taking BO to LHS by taking OC to RHS. So you have AO by BO equal to OC and CO both are same. Now the 10th problem. The diagonals of a quadrilateral ABCD intersect each other at the point O. We have to show that ABCD is a trapezium. Okay, when a quadrilateral becomes trapezium, children, when one pair of opposite sides are parallel. That means if we can show that AB parallel to CD, that means you can write ABCD is a trapezium. So our aim is to show that AB parallel to CD. Okay, so see children, for this problem also we are constructing one simple construction is needed, that is OE parallel to CD. OE parallel to CD by construction. Okay, and since OE parallel to CD, what is our aim? We have to apply basic proportionality theorem. That is why we have drawn in this manner. We constructed OE parallel to CD. Okay, that means you have to consider a triangle having CD is one of the side. That means I am going to consider triangle ADC. Okay, so given this is given children, given that all things you have to write in all the questions, and what we have to show ABCD is a trapezium. Okay, that is understood, and it construction OE parallel to CD. And see children, consider triangle ADC. Since OE parallel to CD by BPT, what you can write? The other two sides are AD and AC are divided in the same ratio. That is AE by ED equal to AO by OC. This is equation number 1. See children, in all the problems we have to use what is given in the question. It is given that AO by BO equal, I am going to apply this given equation, that is CO by DO. AO by BO equal to CO by DO. This is given. Okay, this is given. See, I am making a simple rearrangement in order to suit with this equation number 1. See children, if you can write this AO by, from this AO by CO, so automatically BO will go to RHS in the numerator. Okay, implies AO by CO equal to BO by DO. Okay, I just made a rearrangement. Okay, now from equation 1 and 2, AE by ED equal to AO by OC. Here AO by OC equal to BO by DO, which means you can equate these two. Okay, so from 1 and 2, what you can write? From 1 and 2, you will get AE by ED equal to BO by DO. In both the equations, see children, AO by OC, here also AO by OC, which means you can equate this side, AE by ED and A. So what we have seen? We have now AE by ED equal to BO by DO. See that what is from the figure, what we have now, AE by ED, this ratio AD, okay, its ratio is same as BO by DO, BO and DO. So this is a triangle. If you consider this triangle, which is this triangle ADB, that is a triangle ABD, these two sides are divided in the same ratio. That is we have seen from equation 1. Okay, which means, can you write in triangle, if you consider triangle ABD from 3, what you can write? Since this AE, these two sides are divided in the same ratio, which means this OE is parallel to AB. Okay, OE is parallel to AB by converse of BPT. Understood? If any two triangles, the sides are divided in the same ratio, then that line is parallel to AB. Understood? So now we have OE parallel to AB. Okay, by converse of, from equation 3 we have OE parallel to AB. By construction, what we have constructed, how we started this problem, that is OE parallel to CD. So OE parallel to CD. See children, in from these two, what you can write? AB, since OE parallel to AB, a line is parallel to AB, and that line parallel to the another line implies AB, these two lines AB parallel to CD. See, in this quadrilateral, we started with the quadrilateral ABCD, and now we have seen that this AB and CD are the opposite sides and they are parallel. In that quadrilateral, these opposite sides are parallel, which means ABCD is a trapezium. ABCD is a trapezium. This is the required proof. Okay, so we have completed all the problems under exercise 6.2. So thank you children. Thank you for watching and supporting my channel. Thank you all.